Good morning, class. Today I'm going to be taking you guys through forces, and this is basically an introduction into the forces that you guys need to know for grade 12, especially in the subject of technical sciences. Right, so what's the first force we are going to cover? The first force we are going to cover is weight. Now, another name for the weight force is gravitational force. And what is that? Well, the gravitational force is the force that the Earth exerts on an object that is very close to its surface. And there's a formula for calculating weight, and that formula is weight is equal to mass multiplied by gravity. Now, what is the mass? Well, the mass is the actual weight of an object. Like, let's say, for instance, we have a block, and the mass of that block is 5 kilograms, right? So a lot of people will step onto a scale and have a look down at the scale, and they'll see about 50 kilos or 60 kilos or 70 kilos, and they'll think that is their weight. Well, in fact, that is not their weight, that is their mass. So the M over here stands for the mass of an object. The W stands for weight, and as we said, weight is one of the forces you guys need to know. The G over here stands for gravitational acceleration constant, and it's a constant that is provided to you guys on the formula sheet, and it's always going to be 9,8 meters per second squared. Alright, but that being said, let's jump into an example. So here we have an example. Calculate the weight of the 1 kilogram block below. So there, as you guys can see, it says calculate the weight of the 1 kilogram block. You would think that the weight is 1 kilogram. However, in this case, the weight of this 1 kilogram block would be mass multiplied by gravity. And what is the mass of this block? Well, the mass, as we know, is 1 kilogram. And we're going to multiply that by the gravitational constant, 9,8 meters per second. Once you multiply that two together, you know that weight is a force, and force is measured in newtons. So we have 9,8 newtons when we multiply those two together. And the weight of this 1 kilogram, even though it says 1 kilogram, that's not the weight, that is the mass. The actual weight of the 1 kilogram would be 9,8 newtons. Moving on. So the next force that we need to know, for all intents and purposes, for the most part, is the opposite of weight. And what is the opposite of weight? As you guys can see there, we have weight here at the bottom, and on top we have something called the normal force. Now, what is the normal force? Well, the normal force is the perpendicular force exerted by a surface on an object that lies on the surface. So what does that mean? That sounds complicated, right? So over here we have a block, and we have a force acting downwards, that is the weight. Well, opposite to that force, or at 90 degrees to that force, or sorry, at 90 degrees to the surface, you guys can see there's the surface, right? At 90 degrees to the surface, going upwards, right, we have something called the normal force. So for instance, we do have other circumstances where the surface is angled. Some people will think, if we have a block on an angled surface like that, that the normal force will just act upwards, but that's incorrect. Why? Because here the surface is, and 90 degrees to the surface, the normal force will act in that direction. The force of gravity, otherwise known as weight, in this circumstance will act downwards, and over here that is the regular normal force. Do you guys understand? Right, let's move down. Okay, so here we have another example. It says calculate the normal of the scale below, or the weight on the scale below. So here we have a weight, and they want to know what is the normal force. Well, the formula for normal, or in this circumstance, normal force will equal the weight. But what is the weight actually equal to? As seen previously, weight is equal to mass multiplied by gravity. So if it's equal to mass multiplied by gravity, and that's what the weight is equal to, but the normal is equal to the weight, we can conclude that the normal is equal to the mass multiplied by the gravity. And I want you guys to be very specific when you write down this formula, because you actually get marks for writing down the formula, provided you make a substitution. So let's make that substitution. So what is the actual mass of this 1 kilogram? It is in fact 1 kilogram. Multiplied by what is the gravitational constant? As you guys will know, you've learned since grade 10 that the gravitational constant is 9.8 meters per second. We are going to substitute that in 9.8 meters per second. And what is that answer? Let's go with a bit of a different color. Let's go purple. That answer is 9.8 newtons. Now I made one really pivotal mistake, and that was that normal force is actually a vector. Therefore, because it's a vector, it's a direction, and in this circumstance, the normal force is acting upwards. And why is that? Well, if we look at the surface over here, we have the surface, and we know that the normal force acts 90 degrees to the surface going upwards. In this circumstance, you guys can have a look at that. So the normal force is acting up, and because this is a vector, we're going to say 9.8 newtons upwards to show direction. And why is that? Because a vector, by definition, I'm just going to give you guys a heads up over here. A vector is a physical quantity with magnitude as well as direction. Alright guys, now that we have it out of the way, there's one mistake that I've made, and I'm sure you guys have noticed that, and that is over here. Weight in this circumstance is also a vector, and it does not have a direction. So what would the direction be over here? That's going to be downwards. Right, well, let's move on. Excuse me. Let's move on to the next definition. The next definition, or the next force that you guys need to know, is something called frictional force. To my learners within grade 11 technical sciences that I've taught last year, you guys know that we've covered this over many weeks. And what is the frictional force? Well, the frictional force is the force parallel to the surface that opposes the motion of an object and acts in the opposite direction of the motion of the object. Now that's a mouthful. What does that mean? Let's go into an example. Let's say, for instance, we've got a block and it's on a surface. Well, what occurs between the surface and the block is something called friction, and what causes that friction? Tiny micro bumps within the surface. So the surface is not smooth. At the microscopic level, you have ridges and gaps and everything, right? So you have those ridges and gaps there, and that causes something called mu, either mu s or mu k, and that is the coefficient, excuse me, apologies, that is the coefficient of kinetic friction. Well, what is this coefficient of kinetic friction? Well, that is basically the level of roughness, in layman's terms. It's the level of roughness of the surface. So if you look at this block over here, if we had massive ridges like that over there, it would naturally cause more friction. And because it causes more friction, that will increase the value of our mu, either mu s or mu k, and we'll get into the s and the k in time. However, if, let's say, for instance, we have a surface, and that surface is a bit smoother, the friction would be less and the coefficient of friction in this circumstance would be less as well. So let's go into it again. Frictional force is the force parallel to the surface. So here's a block. There's the surface. The frictional force is parallel. Right? They are parallel. It's parallel. There's the surface. There's my frictional force. It can either act that way or that way depending on the motion of the block. It can either act that way or that way depending on the motion of the block. And it's parallel and it acts in the opposite direction to the motion of the object. So if we have this block going in that direction, if the block is moving in that direction, let's say we have an F applied here and it goes in that direction and the block is moving in that direction, the friction, let's do it in a different color, for this force over here or this direction would act in the opposite direction. However, if the block is moving in that direction, left, then the friction will occur opposite to that. The friction will go, whoopsie, will go right. So that's what this means over here. That opposes the motion. So it's the force parallel to the surface that opposes the motion of the object and acts in the opposite direction to the motion of the object. Right? The Fs stands for the force of static friction. The μs stands for the coefficient of static friction, and N stands for the normal force, which we have covered in the earlier slide. Let's go into an example real quick and we'll conclude with an example for today's lesson and then continue going on.